All right, so for problem 3, I went ahead and sped up things up and go ahead and wrote down. You're going to need to know this is how you go about it. You need to do these 5 things anytime you see a rational function. The first step is always to factor that problem. This is going to factor to be x minus 5 and x plus 1. And this denominator factors, if you take out a 4 and an x as a GCF, it leaves you an x minus 2. Okay? Now, to find my vertical asymptotes, you're going to ask yourself, what can I put in for the x's in the bottom and make those zeros? Well, it's obvious that that's a 2, but right here, if I put a 0 in there, since nothing's added or subtracted from there, that's going to give me a 0. That means my vertical asymptotes are at 0 and at 2. So I'm going to have a vertical asymptote at x equals 0 and a vertical asymptote at x equals 2. Now go through and find your zeros for this. Your zeros are whatever makes the top 0. That's going to be 5, 0, and it's going to be negative 1, 0. So at 5, 0, there's a point, and at negative 1, 0, there's a point on the graph. All right? Remember, your vertical asymptotes and your zeros are also the numbers for your sign chart that divide this thing up into sections. In order on that number line, it's going to be negative 1, 0, 2, and 5. So I need to check the area on the left of negative 1. I need to check the numbers between negative 1 and 0. I need to check the numbers between 0 and 2. I need to check the numbers between 2 and 5. And then I need to check the numbers bigger than 5. So we got this thing checked out. We're going to come back and check the sign chart. I'm going to show you a shortcut on this actually in just a moment of how to do this. All right? But right now, just kind of holding that off, let's finish doing the rest of our checklist. To do horizontal oblique asymptote, always ask yourself if there's a horizontal asymptote. If there's a horizontal asymptote, there is not an oblique asymptote. That's why we haven't had to worry about it the past 2. They both had horizontal asymptotes. If there's a horizontal asymptote, to find that, we go by the rules. The exponents are the same, so we take the leading coefficients. That's a 1 over 4. The horizontal asymptote is at y equals 1/4. At y equals 1/4, you understand that's between 0 and 1. There's a horizontal asymptote going right there. That looks more like 1/2, but for this purposes, you can see what I'm doing. And with a magic marker, it's kind of hard to really show what I'm doing. Be sure to label your asymptotes. So I've got a horizontal asymptote at 1/4. For the y-intercept, put in zeros everywhere you see x's. Everything that's got zeros everything that's got x's goes away, and it leaves you negative 5 over 0. Now, what is negative 5 over 0? Well, that's undefined, which means there's no y-intercept, which makes sense because there's an asymptote on the axis, so I can't have a point on the axis also because there's an asymptote there. So there's no y-intercept. Now do the sign chart. If you pick a number, let's say to the right of 5, something bigger than 5, like 6, and plug it in. It's always easier to plug it into the factored form, so let's do h of 6. That'd be 6 minus 5, 6 plus 1. 4 times 6 there, and then 6 minus 2. Just looking for the signs. That's a positive, that's a positive, that's a positive, tons of positive, tons of positive. Everything here is being multiplied together. That's all positives. That means everything over here is positives. Now, the shortcut for this is the signs will always alternate positive, negative, unless a 0 is repeated on the top or bottom. Notice on problem number 1, I'll pull that back up real fast so you can see that. The only critical numbers were negative 3 and 2. There was nothing repeated. On problem number 2, the critical numbers were negative 1, 3, and negative 3. Nothing was repeated, and the sign chart went negative, positive, negative, positive. For this, because it's got a positive over here, it's going to go negative there, positive, negative, positive. It's going to alternate unless one of the zeros, top or bottom, one of the critical numbers, is repeated. And I'll show you an example of that here in just a moment. As a matter of fact, number 4 is going to have that one. Number 4 has got x plus 2 squared. That means that the critical number, -2, is repeated, so it won't alternate there. Well, that's not this problem. So right here, we're going to use our sign chart and the points and stuff that we've already got. To the right of 5, it's got to go through 5, because that's a 0, that's a point, and it's got to hug that asymptote. It's just going to go up and hug that asymptote. Between 2 and 5, it's got to be below the axis, still going through that point. It's got to go through that point, but it's got to come down and hug that asymptote down. Between 0 and 2, it's got 2 asymptotes. So it's going to have to hug that asymptote. It's going to have to hug that asymptote all above the axis. It's going to look like a little skinny parabola stuck between those 2 asymptotes. Between 0 and -1, it's going to go down, hug the asymptote, and go through that point. And to the left of -1, it's going to be above the axis, still going through that point, hugging that outside asymptote. Notice the horizontal asymptote didn't come into play until I was doing the outside there or the outside there. Horizontal asymptotes only affect bigger numbers or smaller numbers, not the area in between.